Hello everyone, my name is KUMAR from BMFG and my metric number is B0521100096. Today me and my group mates are going to present about combined cycle power generation and I'm with my part which is introduction. So basically what is combined cycle power generation or power plant? It is a simple cycle of a process converting the energy in a fuel into electric power which involves mechanical work. Before this, we used to depend on fuel type and thermodynamic process. The conversion is typically around 30 to 40%. It means a significant amount of the latent energy of the fuel ends up wasted, and this turns as thermal energy in the not exhaust gases from the combustion process. The most common type of plant that to make electricity is combined cycle gas turbine, in short form CCGT plant. The same principle is also used for marine propulsion, which is combined gas and steam, COGAS. By combining two or more thermodynamic cycles reduces fuel costs. Why combined cycle power generation are efficient? There are some major factors and let's look about it. Firstly, combined thermodynamics are low capital cost and lower emission compared to conventional fossil power plants. And also, as I said before, due to higher cycle efficiency, it will cost low. Secondly, shorter construction time compared to conventional fossil power plants. Modular construction with factory plug and play auxiliaries enable faster construction times with less human error. Moreover, combined cycle power generation have higher efficiency and high power density, which is the energy efficient is around 50 to 62%. That's all from me. Thank you.
Assalamualaikum and good morning to Dr. Aida Fazliana and to all who is watching. My name is Muhammad Firdaus bin LAINDON with matrix number B0520100145. I will be presenting about operation and basic principle of combined cycle power plantation. As you can see in this combined cycle power plant diagram, there will be three major parts, which is combustion turbine, heat recovery steam generator or HRSG, and steam turbine, followed by a condenser and a cooling tower. Okay, as we can see in this animation, we will see that there is a combustion turbine, heat recovery steam generator HRSG, and a steam turbine. In the first cycle, fuel is burned and resulting in combustion gases power through turbine generator to produce electricity. After that, the hot exhaust normally lost during this process is captured and routed through the two heat recovery steam generator. This unit will boil water to create steam which spin an additional turbine generator and produce more electricity. You can see that the steam here will turn the steam turbine and power up the generator, and the generator will send the electricity to the tower. And finally, the steam is discharged into a condenser which return the steam back to its liquid state for recycling. And that's explain the work and principle of combined cycle power plantation. That's all from my presentation. Thank you.
Assalamualaikum to Dr. Aida Faizlana and all the students. My name Muhammad HAZIQ HILMI bin ABDUL matric number B0520100035. I would like to present about the basic construction of the combined cycle power generation. This is a 20 megawatt combined cycle power generation which burn natural gas to create electricity. First, natural gas is burned to power gas turbine which hooked up to the generator. The gas turbine is a major producer of the electricity and creates 70 MW. The exhaust from this gas turbine is directed to the heat recover steam generator, which creates steam to be sent to the second turbine. The smaller turbine creates 3 MW of electricity. Now we enter the fuel system. We will see the natural gas pipeline tower to top and down to the right. This plant is also able to be run on heavy and light fuel oil, which are stored with the two tanks in the rear of this area. Pump of the boost oil can be operated via the following switch. Into the fuel system, we will see the oil system wave and or operable and indicator can be read. This instrument communicate with the DCS and update in the real time. We go to left and go to the top of the steam boiler. The waste energy from the gas turbine is used to heat boiler feed water which the create steam. Steam can be redirected to the four different areas: a steam heater, the gas turbine, a vent, and the steam turbine. Now we will ahead to the gas turbine. We get the view of the compressor turbine system. Here, the vibration can be monitored. The igniter statuses can be monitored. Now we will go to the inside of the turbine and get a different view, as we will see the gas turbine as well as a condensate system. Lastly, we will see the steam turbine section. As we approach the steam turbine section, we will be able to see the make-up water tank for the boiler feed water system. This is located in the blue in the front. As we head to the right and the inside, we will see the steam line coming from the steam boiler and upward left. We head the right and we will see the condenser water system below the turbine.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aslam bin ABDUL ASMIN and my matrix number is B052010063. Okay, here I would like to continue to explain about some example of combined cycle power plants in Malaysia. As we know, the combined cycle power plants process is converting the energy in a fuel into electric power, involve the creation of mechanical work, which is then transformed into electric power by a generator in a simple cycle, causing efficiency losses in the process. So, in our country, there are some combined cycle power plants that functioning as electricity generator to occupy the nation needed. First, all of these combined cycle power plants have in Malaysia are mostly owned by ABDUL energy companies. The first combined cycle power plants are Melaka combined cycle power plants that located at Kuala Sungai Baru, Alor Gajah, Melaka. This combined cycle power plants is known as the one largest power plant in Malaysia. This power plant is 2.242 gigawatt power plant that divided into 3 combined cycle blocks of capacity 747.7 megawatt each. The gas turbine of this combined cycle power plant has a net power output of 571 megawatts and offers a net efficiency of 64.1% in combined cycle operation. The electricity generated by the Melaka combined cycle power station will be evacuated into the grid through a 500 kilovolt power transmission line. Okay, next we move to the next example, Telok Gong Power Station 2. This power plant is located at Telok Gong, Melaka. This power plant is a gas and steam turbine project type and can capacitize over 720 megawatt. This power plant run on dual fuel. The primary fuel that used to this power plant is natural gas. In case have a shortage, distillate fuel oil are used as a backup to ensure the power plant is running. The fuel that used in this power plant are all fuel that used in this power plant are produced by the Petronas company. The last one we that I want to explain is Kuala Langat power plant that located at Kuala Langat, Selangor, Malaysia. This is combined cycle power plant and also use gas and steam turbine to generate electricity. This power plant can capacitize over 675 megawatt and run on dual fuel, same function as Telok Gong Power Station 2. The primary fuel that used to this power plant is natural gas, and distillate oil fuel play as a backup in case that have shortage of natural gas. This power plant, for your information, this power plant is sold to Tenaga Nasional Berhad (TNB) with agreement 10 year, and the contract capacity is 762 megawatt. So these are 3 examples of combined cycle power plant that have in Malaysia that functioning as an electric generator to occupy the needed of nation.